What if the scraps from your dinner last night could one day power a plane across the ocean? I know, it sounds a little bit like science fiction, right? But a brand new breakthrough is making this a real possibility. Today, we're going to dive into the incredible science of turning everyday food waste into high-performance, sustainable jet fuel. So to really get this, we've got to look at two massive, and I mean massive, global problems that seem totally unrelated. On one side, you've got aviation. It's responsible for about 2 to 3% of all global greenhouse gas emissions. Then, on the other side, you have this staggering amount of food waste. We're talking over a third of all the food we produce getting lost or just thrown away. They seem like they're in completely different worlds, don't they? And just to really hammer home how big of a deal the food waste issue is, get a load of this number. In 2019, in the US alone, nearly 40 million tons of food waste went straight into landfills. That is just an unbelievable amount of wasted resources, wasted energy, just sitting there. But what if we could actually build a bridge between these two huge challenges? What if the very thing we're throwing away could help us clean up our skies? Well, that is the exact question that a team of researchers decided to tackle head-on. And their answer, it all starts with a process that is basically a super high-tech way of turning trash into treasure. Let's break down exactly how they do it. Okay, so the whole journey from, your leftover pizza to actual jet fuel, it happens in four main steps. First, obviously, you start with the food waste. Then you put it through this process called hydrothermal liquefaction, or HTL for short. After that, it gets a major upgrade through something called catalytic hydrotreating. And boom, at the end, you've got sustainable aviation fuel. So what exactly is that core process, hydrothermal liquefaction? Honestly, the best way to wrap your head around hydrothermal liquefaction is to think of it like a giant industrial-strength pressure cooker. Seriously, it takes wet stuff, like food waste, and puts it under insane heat and pressure. It's basically copying the exact same process that nature uses to create crude oil deep in the earth, but instead of taking millions and millions of years, HTL gets it done in just a few minutes. So what comes out of this pressure cooker is something called biocrude. It's this thick, really energy-dense oil, and it's a fantastic first step. But, and this is a big but, you can't just pour this stuff into a jet engine. Nope. It's still packed with impurities, things like oxygen and nitrogen, that have to be scrubbed out before it can be used as a real drop-in fuel. Right, so this biocrude, it needs a serious upgrade. And that brings us to the next absolutely crucial stage, a high-tech purification process that's going to turn this promising oil into a pristine, ready-to-go fuel. This whole upgrade step is called catalytic hydrotreating, and in this particular study, the scientists used a very special secret ingredient, a catalyst made of cobalt and molybdenum. This is really what does the heavy lifting, scrubbing that biocrude clean right down to the molecular level. The easiest way to picture this is to just think of it like a super advanced chemical filter. As the biocrude flows over this catalyst with more heat and pressure, the catalyst just rips out all the junk, the oxygen, the sulfur, the nitrogen, and it leaves behind these pure hydrocarbon chains. And guess what? That's exactly what jet fuel is made of. Okay, so we've taken food waste, we've turned it into biocrude, and we've purified it. But here's the million-dollar question. Is it actually any good? Can it meet the incredibly strict standards that are required for aviation fuel? Well, let me tell you, the results are pretty amazing. First things first, let's look at the molecular structure. This chart here shows you the distribution of carbon molecules, and what you're seeing is a huge success. The average carbon number for their fuel came in at 10.7. Conventional jet fuel, it's 11.4. That is so close, it means, structurally speaking, this is the right stuff. It's a near-perfect match. And here it is. This is the real mic drop moment. The fuel was put through all the official, internationally recognized safety and performance tests. These are called the ASTM standards. And as you can see, it passed. Density, flash point, freeze point, it hit all the marks. And what's really incredible is that it did this without having to be blended with any fossil-based jet fuel at all. This stuff is the real deal, all on its own. And just look at how clean this fuel is. The purification process worked like a charm. They achieved complete removal of oxygen, complete removal of nitrogen, and the sulfur content, just 10 parts per million. The legal limit is 15. This is a remarkably pure fuel. Okay, so the science is fantastic, no doubt. But what does all of this mean for the big picture? This is where we zoom out from the lab and start talking about what this could do for the planet and about creating what you could call a truly circular sky. To actually measure that impact, the researchers used a metric called the circularity index. It's basically just a score that tells you how good a system is at closing the loop. Reusing and recycling resources instead of just using them once and throwing them away. The higher the score, the better. So, what happened when they modeled applying this new fuel pathway to the entire US aviation industry? The Energy Circularity Index shot up by 31.1%. Wow, that is a massive leap forward in how efficiently we could be using the energy that's just locked up in our waste. And on the carbon side of things, the story is just as exciting. A 17% increase in carbon circularity. What this means is we're capturing carbon that would have just sat in a landfill, and we're putting it back to work. It's effectively closing that carbon loop and shrinking the net carbon footprint of flying. Now, the researchers are being very realistic here. As this quote from their study points out, food waste is a powerful tool, but it's not going to solve the entire problem all by itself. Think of it as a huge, critical piece of a much larger puzzle, one that's going to need other sustainable sources to create a truly circular bioeconomy for aviation. So it all comes back to this one kind of wild idea. This research shows that the potential is absolutely there. What we've always just seen as garbage could be a key ingredient for a cleaner, more sustainable future in the skies. So, yeah, the next time you scrape your plate, you might just be looking at the future of fuel.